Hello my dear students, welcome back to NEET 1. So I hope you are preparing for your IP as well as your JEE NEET and EAPCET exams without having any distractions. Okay, so right, so in the last sessions we have covered this alcohols, phenols, ethers, where I have covered their like important classifications as well as the IUPAC nomenclature and basic chemical reactions, and which are very helpful for preparation of alcohols, especially alcohols. And now in this class we will be discussing about chemical properties of alcohols. Okay, so what we are going to prepare, what we are going to discuss, chemical properties of alcohols as well as phenols. Okay, so these sessions are highly helpful if you are preparing for NEET, JEE or EAPCET exams. Okay, right. So just follow the class till the end so that you will get complete clarity on chemical properties of alcohols and phenols. Okay, now here I have a very important classification here. How can we see the difference between the chemical properties of alcohol when we compare with the phenol? Okay, let us discuss this here. First of all, look at here, I am treating alcohol, given ROH indicates alcohol. So alcohol, upon treating with sodium metal, what happens? It will form alkoxide ion. See, if it is ethanol, we are going to get ethoxide ion. So you are going to get RO minus and Na plus. Okay, so during this process what happens? This hydrogen comes out as a proton, like hydrogen gas is released here. So half H2 you can write. Okay, like this with the sodium metal it will take. Similarly, even if you are doing with sodium hydride, okay, so sodium hydride is a strong base here, abstract this proton from alcohol and forms alkoxide ion, respective alkoxide ion, and sodium metal here, Na plus is there, like that it will be. Okay, and H2 gas is released. Okay, hydrogen from here and hydride ion from here, proton and hydride ion forms H2 gas. Okay, now alcohol does not react with sodium hydroxide. See, we know sodium hydroxide is a base and we know we are studying it as a strong base by comparison to the ammonium hydroxide, which is a weak base. This is a strong base we are saying, but this NaOH is not strong enough to abstract this proton from alcohol. Okay, so remember this. The next one here means this is one basic reaction you need to remember, and here diazomethane, methane is there with the NH2. So CH2N2, CH2N2, this combination is called diazomethane. So there is no reaction of alcohols with diazomethane, okay, but same diazomethane with alcohol reaction takes place in presence of Lewis acids like BF3, okay. So that you are going to get here RO, see this is CH2 unit and this is hydrogen converts into CH3. So you are going to get a like ether. Okay, ether which is having a methyl group at one side of the oxygen. Okay, so yeah, so we are going to get ether with the help of alcohol with the diazomethane with the help of Lewis acids like BF3. Okay, so this is one of the important reaction to be remembered. Okay, so in absence of BF3 there is no reaction with alcohol and this diazomethane. Okay, in presence of Lewis acid like BF3, yes, reaction is taking place and giving you ether as a product. Okay, and sodium bicarbonate is a weak base that cannot abstract a proton from alcohol. Okay, this is what you need to understand here, or you need to remember here. And the next part you need to remember here is, let us compare the chemical properties, same reagents I will be taking with the phenol. Okay, so now phenol is treated with the same things. The first step is to be treated with what? Sodium metal. So see, remember phenols are more acidic. What I am saying? Phenols are more acidic than alcohols. Remember this statement. Okay, so why phenols are more acidic than alcohol I will explain. Okay, as of now you just follow these steps what I am doing here. See, alcohol treated with sodium metal, in the same manner phenol is treated with sodium metal. Okay, since it is more acidic, phenol is more acidic than alcohol, yeah, it will form sodium phenoxide ion like O minus phenoxide ion plus Na plus, hydrogen gas is released here also. Okay, and when it is come to NaH, sodium hydride, yeah, same reaction takes place here also, phenoxide ion is formed, same product is formed here also, and hydrogen gas is released. Okay, similar to that. Okay, and here you need to remember that phenol can react with NaOH, sodium hydroxide, and forms a phenoxide ion. Okay, so this reaction says that what phenol is more acidic than alcohols, because sodium hydroxide is not abstracting proton here, but here it is taking place. So this is the important difference or important reaction to be notified here to differentiate alcohols and phenols acidic nature. Okay, and here diazomethane, when I am treating this with diazomethane, phenol directly react with diazomethane, there is no requirement of BF3, and to form respective product. What is the product formed here? So phenol will be converted into anisole. What do we mean by anisole? It is an ether. Okay, so same thing, see here you have ROH, right? So you are writing RO and this hydrogen, this methyl, this CH2 unit, you are writing it as a methyl. Okay, similar to that, here you can see phenol, just remove this, this hydrogen and this CH2 unit converts into CH3. So that compound is called methoxybenzene, so you can call it as a anisole. What is the name of that compound? Anisole, remember that. Okay, right. And you know, phenol does not react with NaHCO3. So NaHCO3 is a weak base, it won't show any reaction here. And one more important point you need to remember here, whenever there is a phenol with electron withdrawing groups, for example electron withdrawing groups means, here I am saying phenol is there, along with that I have a nitro group over here and one more nitro group over here. So what does these nitro groups do? That will withdraw electrons towards themselves. Okay, so these electron withdrawing groups increases the acidic nature of phenols. What they will do? Electron withdrawing groups increases the acidic nature of phenols. Now if you treat this with NaHCO3, what I am saying, if you treat this with NaHCO3, yes, now the reaction takes place. Now what happens? This proton will be removed out. So what makes the difference? Here it is a simple phenol, but here the phenol is having electron withdrawing groups. So electron withdrawing groups increases the acidic nature of phenols. Okay, so that you are going to get a conjugate base. What is a conjugate base formed? Phenoxide ion with nitro groups, electron withdrawing groups like this. Okay, this is one of the important reaction to be remembered. Okay, right. So now sir, why it is taking place here? Why this acid base reaction is taking place in presence of electron withdrawing groups? Why not in simple case? Because here the phenoxide ion formed here can be stabilized by these nitro groups, electron withdrawing groups, by withdrawing the electrons. Okay, by the conjugation of this pi electrons. See, so this ring pi electrons and the negative charge of oxygen are in conjugation. Okay, so due to this conjugation with these nitro groups, what happens? The stability of this conjugate base increases. So due to more stability of this conjugate base, this trinitrophenol is more acidic. The electron withdrawing group containing phenol is more acidic than normal phenols. Okay, so now what is the name of this compound? Yes, you need to remember this. This is called picric acid. What is this? So picric acid. Okay, see, the name in itself indicates a picric acid. Generally what we know, organic acids means we think that carboxylic acids. Not only carboxylic acid, here we have a picric acid. See, they will give 4 names: benzoic acid, acetic acid, formic acid, oxalic acid, and something like picric acid. Which are the following does not contain a carboxylic acid group? Picric acid. The remaining names which I have mentioned, all of them have COOH group, carboxylic acid group, but picric acid does not. So this is the main difference, like you need to remember when you are understanding or when you are learning their common names. Okay, right. So is there any confusion in the discussion? Yes, if there is any confusion in the discussion, please let me know in the chat box. And if it is clear, please click on the like button. Those who are in the live session, the concept, the content that we are discussing here, if it is clear, please click on the like button so that it will reach others also who are preparing for the exams. Okay, right. The next discussion here is acidic nature of phenols to be discussed. Okay, so what I told you, alcohols, phenols, which is more acidic here? Phenols are more acidic. Okay, now between the alcohols, between the phenols, if we compare, which are more acidic here? See, let us take here acidic nature of alcohols first. Acidic nature of alcohols. Okay, see what I am writing, you just remember this order. Water, normal water molecule, water is more acidic than alcohols. What I am saying, water is more acidic than alcohols, except methanol. So methanol is more acidic than water. Okay, so this is the acidic nature order of alcohols to be remembered. Okay, methanol is more acidic than water, more acidic than water is more acidic than other alcohols like ethanol and water. Water will be more acidic. Like this you need to remember here. And the next one is, now I have different alcohols. Let us say I have CH3, CH2, OH, and one more thing here, CH3, CH2, OH, here writing it as NO2 group. This is A, this is B, and one more C is CH2OH, CH2, and here it is CH3. So now what makes the difference here? See, the first compound, A compound is simple ethyl group is there, alcohol is there, ethyl alcohol. Here you have ethyl group with nitro group here. So nitro group is what? It is an electron withdrawing group. And here you have ethyl group having one alkyl, methyl extra. So you can say these alkyl groups are, these are simply called as electron releasing groups. Okay. So now what I am asking, acidic nature of these alcohols, we need to compare this acidic nature of alcohols, which is more acidic I am asking. How do you say here? See, acidic nature means nothing but they should release this proton right now. So if they release proton, what happens? They will form respective conjugate bases, O minus, like this, okay, after releasing this H plus ion. So if their tendency to release this proton is more easy, or more tendency to release the H plus ion, more is the acidic nature of that compound. Now tell me, out of these three, which is having more acidic nature, more tendency to release H plus ion? Tell me, how can we answer that? See, here what type of group we have? Electron withdrawing. If there is electron withdrawing group, after forming this conjugate base, after acid releasing H plus ion forms this conjugate base, this negative charge will be more withdrawn or more stabilized by electron withdrawing group. So wherever we have electron withdrawing groups, that alcohols are more acidic than the other. So I am simply mentioning two statements. Electron withdrawing groups increases acidic nature of alcohols. Okay, and whereas electron releasing groups are present here. Electron releasing groups destabilizes the conjugate base formed. Okay, releasing groups decreases acidic nature of alcohols. That's it. Okay, now tell me, out of this A, B, C, which is more acidic? A, B, first B, after that A, and least is C. Why like this? Because there is no releasing group, here we have a releasing group. That is the difference. Okay, this is the answer you need to give. Okay, now this is about acidic nature of alcohols. Now if you want to compare acidic nature of alcohols with phenol, so tell me which is more acidic. I told you phenols or alcohols. Phenols are more acidic than alcohols. Phenols are more acidic than alcohols. Now within the phenols we need to compare. One of the very important question that comes in the exam is like this. A simple phenol is given. It's a most frequently asked question in the exam. Acidic nature of phenols. Okay, phenol with nitro group over here and a phenol with electron releasing group over here. Now tell me, A, B, C, which is more acidic here? Huh? B is more acidic. Why B is more acidic? Because presence of electron withdrawing group. So electron withdrawing groups, see why phenols are acidic? See, remember all organic acids are weak acids first of all, but within the weak acids we need to explain which is better or more acidic. See, phenols acidic nature is presence of this hydrogen and oxygen. So O minus and H plus. So if this phenoxide ion is more stable, then that phenol will be more acidic. See why I am saying this phenoxide ion should be more stable than this phenol is more acidic, because here I have mentioned a equilibrium symbol now. If this product formed is more stable, then equilibrium easily moves forward. So it means acidic nature will be increased. So in order to stabilize this phenoxide ion formed, that negative charge must be shared between the other atoms also. More stabilization takes place. That should involve in the conjugation. So it will be involving the conjugation like this now. So if there is any electron withdrawing groups at either para positions or at ortho positions, that phenoxide ion stability increases. Now tell me, do we have any electron withdrawing groups in the first case? No. In option A, no. In option 2, yes. After releasing this proton, that phenoxide ion can be stabilized by this nitro group. Okay. And now what about this group here? Alkyl group. Alkyl group means what? Releasing group. See, electron releasing groups do not stabilize the phenoxide ion. That will destabilizes the phenoxide ion. Okay, because that also provides electrons into the ring, that will be destabilizing the system. So if I add one more compound, now you tell me, first of all you tell me for these three compounds whatever we discussed till now, A, B, C, which is more acidic here? B. After B, between C and A you tell me? See here electron releasing group is present, here there is no group. Having no group is better having electron releasing groups. Okay, so A, C, and now this is, you got the clarity. Now nitro group, here also we have, now I am adding one more extra option D. Now tell me, nitro group is present, but what is the position of the nitro group? Meta position. So there is no involvement of mesomeric effect at meta position. So it won't directly participate in conjugation with the phenoxide ion. Therefore inductive effect is not seen in this case, only minus I. Mesomeric effect is not seen in this last case, only minus I, that is inductive effect, minus I effect only observed here. So therefore what happens, tell me? So B will be more acidic. After that, here at least electron withdrawing group is present, but which is more effective here? It is minus M effect is there, minus I effect, both inductive and mesomeric effects are there, that's why B. After that D and A, C. This is how you need to answer. Okay. So now instead of asking only about acidic nature, like directly instead of giving like acidic nature of molecules, they may ask the same question in the other formats also. I will tell you. Acidic nature of the following phenols will be. They will ask like this. Or which are the following is most acidic. You need to choose one. Okay. Or other ways, see acidic nature directly proportional to Ka. What is this Ka? This acid dissociation constant is there now. So how do you write? Concentration of products by concentration of reactant. So more is the concentration of product, more is the acid dissociation constant here. Okay. So if this Ka value is more, that is more acidic. So acidic nature is directly proportional to Ka or directly proportional to concentration of that H plus ion. Okay. So now there is something called pKa. What do we mean by pKa? pKa is nothing but minus log of Ka. So if it is more acidic, Ka value is more, but pKa value will be less. So Ka, pK are inversely related, you can understand in this way. Okay, if more Ka, if more acidic, lower pK. Like that you need to understand this. Okay, if a compound is more acidic, its Ka value is more, pK value will be less. That's it. This is a concept you need to remember. So which are the following phenol have highest pKa? They will ask. So which is least one? C is least. So that will be having highest pK. Like that you need to answer during the exam. Okay. Is this clear? Yes, next we will see some chemical reactions of alcohols we will see. See, this is one of the question that I wanted to explain, because we already discussed about SN1, SN2 reactions in the last classes. Now here it will be useful, E1, E2 elimination, all these things are discussed. Okay, now tell me what happens here. H plus ion is given under heating condition. Now what happens? Just look at here, CH2OH. H plus ion is mentioned. Now what happens? This H plus ion is taken by lone pair electrons of oxygen. Now what they will form? See, CH2OH and H, positive charge on the oxygen, right? Like this you are going to get. See, water molecule H2O kind of thing is formed with a heating condition. Now whenever you are heating, what happens? Oxygen is electronegative atom that should not bear that positive charge. So it will try to take this bonded electrons with itself and breaks and leaves out as a water. So goes out as a water molecule here. Now what is the charge creating on the carbon here? Tell me. CH2 plus. This is a primary carbocation we get. Okay. But if you see, there is no such options in the question, right? So now what happens is, this is a primary carbocation, right? So primary carbocations are less stable. Now what happens is, if there is any chance for rearrangement, then rearrangement takes place. See, a 5-member ring with primary carbocation is there. Now what happens is, this ring expansion takes place in this way. Now if ring expansion is taking place, what happens? See, a 5-member ring becoming 6-member, more stable ring is formed. So that you will get a 6-member ring in this way. After getting, see, a bond disconnection is taking place between, see, if I number it like this, 1, 2, 3, 4, 5, 6. So you are disconnecting a bond between 2 and 6. That bond is disconnected with 2 and that will be shifted on to 1. So the second carbon should get a positive charge. So that second carbon, let us say this is the second carbon, positive charge. Okay. Now to this positive charge, hydrogens, alpha positions hydrogens are there now. So that will be getting deprotonated to give an alkene. Like this. This is your final product. Okay. So this is how you need to write the mechanism. So where do we have that option? 3. Okay. Right. In the similar manner, so before going to other question, let me give you one more example. See, here I have OH group. Okay. So you need to add H plus ion under heating condition. Now what happens, tell me? What happens, tell me first? Tell me, what is your answer? Yes, yes, you can try easily. First remove, add H plus ion, remove OH as water. Then what happens? For removing this H, adding H plus and remove OH, so that it will be removed as water here, like water is formed first, then remove it, positive charge we get. Okay, after that tell me what happens. See, to these, whatever the OH group attached carbon is there now, so this is called alpha carbon. What is that? Alpha carbon. Alpha carbon. The adjacent carbons are called beta carbons. On beta carbon, if we have any protons, those are called, considered as beta protons. What I can say? Beta protons. Okay. So these are beta protons now. Now when you remove this water, you are getting a positive charge on that carbon, alpha carbon. So it remove protons from beta position. So now we have beta protons on this side as well as the outside terminal. Okay, so now I can remove protons from inside carbon or from this outside carbon. Only one proton is removed. See, let us say I am removing a proton from inside, so that you are going to get a double bond here like this. Right now an alkene is produced in this way. Or if you remove from outside, it a double bond like this. Yes or no? Out of these two alkenes, which is which is more stable alkene? Tell me, out of these two alkenes, which is stable alkene? See, this one is more stable. Why it is more stable? Because more the number of alpha hydrogens to the alkene carbons, that will be more stabilized by hyperconjugation. How many hyperconjugations are possible? See, I have written it like this. See, try to understand in this manner. See, I have mentioned it in this way. See, the double bonded carbons are there now. To that, adjacent carbons are called alpha carbons. How many alpha carbons are there? 2 alpha carbons. And how many alpha hydrogens are there? See, whatever the hydrogens present in alpha carbons considered as alpha hydrogens. So here 3 and here 3. So 6 alpha hydrogens are there. 6 times it will get stabilized by hyperconjugation. So more the number of alpha hydrogens, more is the hyperconjugation and more will be the stability. So out of these two, which is more stable alkene? This one. Since it is more stable alkene, it will be formed as a major. Okay. So because why I am saying this? See, there are two possible ways to deprotonate, either from inside or from outside carbon. Okay. So these are the two possible products. If I remove from inside, you will get this. If I remove from outside, you will get this. But out of these two, which of the following is major product, they will say. So the more stable alkene will be formed as a major. Is this clear or not? Right. Clear now? That's it. Okay. Next. Next thing is, see, what I am doing here is, tell me, what is the major product again here? What is the major product? Tell me first. Remove OH. After that, add H plus, remove it as water. So after that, you will get a positive charge here, like this. And after that, yeah, so you can deprotonate using these beta protons or this beta proton. But which will be giving you major product? Tell me. Inside internal alkenes or terminal alkenes? Which is major? Internal. So it means remove proton from here, like this. This is the major. This is a major product. What is a minor product? You can say the terminal alkene. Okay. And these internal alkenes are called shades of product. What I am saying? These are called shades of product. Okay, this more stable alkene, these internal alkenes are called shades of product. Okay, and these terminal alkenes formed now, these are called Hoffman product. What they are? Hoffman product. Okay, out of these two, which is major, which is minor, they will ask. See, if the eliminating groups here, whatever we are removing, they are small groups. Okay, we will get an internal alkene. This is a shades of product. Okay, there are some conditions in which we will get a Hoffman product. I will explain that. Okay, right. This is discussed, and here you can see one more interesting question. Here we have, see, the major product. This from JEE mains. Anyways, you can able to do this. See, the major product P of the given reactions where Me means methyl. Okay, then how can you do this? Tell me. Add H plus ion to this OH. Remove it as water. So if you remove it as water, what happens? Tell me. So we will get positive charge over here. See, this positive charge carbon is a secondary carbon now. So now what happens, this methyl group migration takes place and gives you positive charge like this, right? So now what happens next, this is a positive charged carbon now, so there is no other reagents here, okay. Now what happens here is, from the adjacent carbon here or from here a proton is removed, but we know more stable alkene, like more substituted alkene is formed as major, because it should be a more stable one, so that you will get double bond here. So this kind of product, where do we have? That's it, that will be your answer. Okay, clear now? Yeah. So one more interesting question here we have. So just try to answer me that. What they are saying? 100 ml of a solution of ethyl magnesium bromide and treatment with methanol produces 2.24 liter of gas at STP. What is the gas produced, or the weight of gas produced? How can you solve this? Yes, those who are watching in the live session, so just try this question. In the last class already I have explained this. Okay, if you are unable to answer, you just go and watch my previous session on this discussion. Okay, right. Next one here is, yeah, oxidizing agents. Now we know alcohols are of different types. What are the different types of alcohols we have? What are the different types of alcohols we have? See, primary alcohol here we can write like this. Okay, or secondary alcohol means if OH group should be attached to a carbon, that carbon should contain two other carbons at least. Okay, and tertiary means OH group containing carbon should surrounded by three other carbons like this. Okay, this is primary, secondary and tertiary. Okay, so now these are called oxidizing agents. What they are? Oxidizing agents. The first oxidizing agent is KMnO4. Try to follow this table so that you will get complete clarity on this oxidizing agent, direct products. See, primary alcohols, upon treating with this KMnO4, converts into carboxylic acids. How they will be converted? Carboxylic acid. Okay, whereas secondary alcohols converts into ketones. How they will be? Ketones. Okay, and tertiary alcohols, no reaction. What happens? No reaction. Okay, so even with K2Cr2O7 also, primary alcohols converts into carboxylic acids, same like above. Okay, and here it is ketones, and there is no reaction here. Okay, when it comes to Collins reagent and pyridinium chlorochromate, all these things, here it will be again carboxylic acid. Okay, and with PCC it will be aldehyde. What it will be? Aldehydes. Okay, and with Jones reagent it will be carboxylic acid. Final product formed is carboxylic acid. But if it is a very low conditions, very low temperature conditions, first it will form aldehyde. Okay, but remember with Jones reagent at normal conditions, that will primary alcohols gives carboxylic acids. Okay, with this chlorine it will be forming aldehydes. What it will be forming? Aldehyde, primary alcohol. With copper we will be getting aldehyde here. What we are getting? Aldehyde. Okay, and when it comes to this one, here it is again ketone, like ketone here and ketone here also, and here also ketone. Jones reagent here also ketone, and this is also ketone, and here also ketone. Okay, when it comes to this tertiary alcohols, no reaction, no reaction, no reaction, no reaction. Until here it is no reaction. But with copper metal, what happens is dehydration takes place. See, this is OH group. See, 300 degrees Celsius we are using, high temperature now. So water dehydration takes place. So from here a beta proton is removed. So OH and proton. So removed and removed as a water, so that you will get a double bond here. So you will get a alkene. What you are going to get? An alkene. If this is the alcohol if we are taking, then the product formed will be like this. So tertiary alcohol now you will get an alkene like this. Okay, this is the table to be remembered. Okay, right, one of the important table. Okay, so now the question will be in this manner. So excess quantity of KMnO4 we are taking here. What happens, tell me? First of all, identify to the substrate what are the things we have. OH group. Which type of OH group it is? Secondary OH it is. And what about this OH group? Attached to a carbon, that is attached to only one carbon. So primary. So now we know with KMnO4, primary converts into carboxylic acid, secondary converts into ketone. Okay. So how many carbons are there? 1, 2, 3, 4, 5. So write 5 carbons first. Okay. So this will be converts into ketone. 1, 2, 3, 4, 5 now. 1, 2, 3, 4, 5. So here you are going to get a carboxylic acid in this way. That's it. This is your final product. Okay. So this is how the basic difference you need to get understood. Okay. Right. The next, oxidation of allylic alcohol. What we are doing? Oxidation of allylic alcohol. See, allylic alcohols are there now. Allylic means what? There should be a double bond here and here OH group should be there. Okay, like this. Okay, these allylic alcohols upon treating with MnO2, what is that? MnO2 converts into respective carbonyl compounds. If it is a primary allylic alcohol, gives you aldehyde. Secondary gives ketone, like that's it. So secondary means what you should get into your mind? Ketone all the time. Okay, primary means it might depends whether it is carboxylic acid or it can be aldehyde. Depends on what type of oxidizing agent we are using. Okay, and in presence of KMnO4, K2Cr2O4, K2Cr2O7, Jones reagent, all these things gives you carboxylic acids. Okay, and PCC, pyridinium chlorochromate, gives aldehyde. Okay, gives you primary alcohols to aldehyde conversion. Okay, remember these things. Okay, so the next reaction of diols with HiO4. This is also one of the very important interesting discussion. See, especially this will be useful when we are discussing about carbohydrates, biomolecules, carbohydrates are there now. So there it will be useful. Anyways, here I will be explaining, just follow me. See, CH2OH is there. See, diols means on 1, 2, like see, carbon, carbon. So at first position we have OH, second position also we have OH. How many OH groups are there? 2. So you can say diol, 1, 2 diol. Particularly the name of this compound is ethylene 1, 2 diol or ethylene glycol. What is this? Ethylene glycol. So now what happens with HiO4? So HiO4 will break this compound. Okay, so how it will be breaks this compound? See, wherever you have OH group containing carbons are there now. Group containing carbons are there now. So break that bond like this. Okay, in periodic acid and insert one OH group over here and one over here. So what you are doing? That carbon-carbon bond is broken and inserting OH. That's it. So you can write CH2 group, already one OH group is there, and what you are doing? One more OH group we are inserting here. So like this. Now what to do? See, on same carbon, if more number of water like OH groups are present, more than one OH group is present, dehydration takes place. What happens? See, OH, remove water, possible number of water molecules. Yes, like this we can remove now. If you remove, what happens? Carbon is there. How many hydrogens are there? One hydrogen, second hydrogen. Next one is one more oxygen is there. So if I write one oxygen with single bond, valence is not satisfied. So make a double bond. So you are going to get an aldehyde. Okay, like this. Okay, so same story applicable for this side carbon also. Okay, therefore how many moles of aldehyde is produced? 2 moles, because same are there here. Okay, now same concept let us apply for higher hydroxy compounds. Like let me write CH2OH, CH2OH. Now try to add this periodic acid. What happens? Tell me. Same story, what I told you? CC bond break, OH, OH, break, OH, OH. Now what happens? This will be CH2OH, CH2OH, this OH. Okay, same kind of compound formed downside also. So 2 moles like this plus CH, this middle one, above one OH adding, below one OH, like this. Right now, after this what I told you, if on same carbon more than one OH group is present, what we need to do? Remove water molecule. So remove possible number of water molecules. See, one O and OH. If you remove like that, you will get H2O. That is nothing but aldehyde, formaldehyde. So how many moles you are getting like that? 2 moles. So 2 moles of formaldehydes. One is from above side, one is from below side. And that middle one is converting into 3 OHs are there now. So now what happens, tell me? H is there, C is there, OH, OH, OH. So remove water molecule like this. Okay, what are the remaining things we have? See this OH now, OH, and one more is hydrogen, and one oxygen. So you are going to get a carboxylic acid. So you got formic acid plus 1 mole of formic acid, 2 moles of formaldehydes from 1 mole of glycerol. Okay, that's it. This is what you need to understand from the chemical reactions of periodic acid. Okay, and one more reaction here is pinacol-pinacolone rearrangement. Okay, pinacol-pinacolone rearrangement, one of the important reaction for JEE students. Anyways, it will be useful for everyone. Let me explain you. See, what happens here is this reaction. So pinacol-pinacolone means, first of all, what do we mean by pinacol? Pinacol means it is 1,2 diol. See, 1,2 diol means I told you that on adjacent carbon there should be OH groups attached like this. Okay, so now some other alkyl groups will be there here. Okay, let us say here I am writing one methyl group, and the next one phenyl group. Okay, and that side one hydrogen. Okay, and after that one not hydrogen, let us say one ethyl group, or okay, let me write methyl group like this. Okay, and here same. Okay, like this I am writing. Now what happens, tell me? See, this is a pinacol. What is this called? Pinacol. So pinacols 1,2 diols treated with acid catalyzer. It means treated with some H plus proton. Okay, so acid catalyzed rearrangement of 1,2 diols to ketones, okay, is called pinacol-pinacolone rearrangement. So a pinacol is converting into a pinacolone. Pinacolone is nothing but our ketone. Okay, so this conversion is called pinacol-pinacolone rearrangement. Now this proton should be added to one of these OH groups, because we know hydroxy group will abstract this proton. But out of these 2 hydroxy groups, which will abstract this proton? Because both of them are OH only. Okay, so how can you decide this step is, when you add this OH, H plus to that OH, we need to remove it as a water molecule. Huh? So if it is removed as water molecule, we are going to get a positive charge. If I remove this OH from here, we will get a positive charge here. Or if I remove this OH group, we are going to get a positive charge here. Out of these 2 positive charges, where positive charge is more stabilized? Here it is a methyl, here also methyl. This is phenyl ring. This is phenyl having an alkyl group here, releasing group. So this group will stabilize as carbocation more effectively than this. So therefore, you need to add a H plus ion, add this H plus ion to that OH group, which generates a more stable carbocation. Which is generating more stable, this one or this one? Here. So you need to remove this OH group by adding H plus. Okay, this is a primary step where most of the students will get confused, or they will do wrong here itself. Okay, if this step is gone, everything will be collapsed. Okay, out of these 2, this OH group will be removed. Okay, so now tell me what happens. C H3OH CH3 so OH, so it removed as water, so we get a positive charge here, right? So after this, yeah, look at here. Now what, there is no other things to add here, only H plus ion is there, no other reagent to attack over here. Okay, H plus won't attack here because already this fellow is electron deficient, here also carbocation electron deficient, so no chemical reactions between them. Now what is the alternate we have here? See, there is a lone pair electrons on this oxygen, right? So that will be gives to this carbon. Why it is giving to the carbon? Already carbon is having 4 bonds, because this carbon need something to attack on it, right now, because it is electron deficient. So one of this alkyl group, either this methyl group or this aryl group, will migrate from this carbon to the adjacent carbocation. Okay, now out of these two groups, who will migrate most generally? How do you remember? The one which is having more electron density. What I am saying, more electron density group containing compound or species will migrate to there. So out of this methyl and phenyl, phenyl is having more electron density, so the migrating aptitude of phenyl is more than this methyl. So which will migrate here? Phenyl group. Okay, so if it is migrating there, what happens, tell me? So CH3, this is CH3 and adjacent carbon, here CH3 is there. Okay, so this phenyl group migrated onto this now, so right here like this. Okay, and here OH group, see, if this group is migrating along with this bond, so what is the charge you are creating on this carbon? Positive. So to that, this lone pair electrons of oxygen is given, so that you are getting a ketone. What you are getting here, see, it is there like this, it is giving a pi electron like this by deprotonation. Okay, so what we got, a pinacol is converting into pinacolone, a ketone is formed. So this is what happens in pinacol-pinacolone rearrangement. Yes, someone in the chart box asking, sir, why we will get a positive charge on removal of water? See, just take one simple example, ma. Whoever asking this question, let us take one simple example here. Something like this I am taking. To this I am adding a proton. What happens? Lone pair electrons of oxygen is given to the proton. Okay, now what it is forming? R CH3 H OH. This is newly added H. Let us say this is newly added H. So that oxygen is giving its electron now, so that it will get a positive charge on oxygen. Okay, now tell me, out of this carbon and oxygen, who is electronegative? Oxygen is electronegative. Now what it will do? It will polarizes its bonded electrons and drags towards itself, because it is having positive charge. To neutralize that, what oxygen will do? It will attract the bonded pair electrons towards itself, because it is more electronegative, having a positive charge. So it will not tolerate that positive charge, that's why it will drag the sigma bonded electrons towards itself. So now if it is dragging the electrons, oxygen is dragging the electrons, means now what happening, both the electrons which are present in this bond are taken by oxygen only, so that carbon is losing the electrons now. So if you are removing electrons, if a species is losing the electrons, that species should get a positive charge. That's why whenever bond is breaking, whenever we are removing water from these alcohols, carbon will get a positive charge. This is a simple way to understand. Okay, I hope the discussion is clear, and whatever you asked me in the chat box is also clear. Okay, so breathe. If this is clear, yes, mention clear in the chat box. If there is any confusion, ask me. Okay, right. Right, next few more things we'll discuss. You, those who are watching it in online session, in the live session, you just try this, just post your answer in our telegram group. Okay, join our telegram group, that will be provided, link will be provided in the description box. So join there and you just post your answer in the telegram group, or you can also share this to our direct WhatsApp number which is given in the description. Okay, so I will be looking into it, based on your response I will be explaining this. Okay, it's very easy. So what happens, first add H plus ion to one of this OH group, remove it as water, and you will get a positive charge here. A 4-member ring is formed now. We are 4-member ring can get rearranged to 5-member ring. Okay, that's how you need to follow the steps. You just try, okay, and tell me your answer in the chat box. Yeah, this is also done. So what I told you, there is something called migratory aptitude. Which group I told you migrates more, phenyl group is more than methyl, like that now. So aryl groups migrates more easily than alkyl group. In alkyl groups also tertiary first, secondary, primary, last is methyl. Okay, and within the aryl groups, sir, within the aryl groups, if I have different groups, for example, there is simple phenyl, this is also an aryl, and one is methyl group containing phenyl. So which will migrate faster, sir, means this is having more electron density now, so that's why it is having more migratory aptitude, like that. Okay, the next. What about these reactions of phenols? So phenols will undergo aromatic electrophilic substitution reactions. Okay, so it means you are treating phenol with HNO3 with what? Dilute HNO3 at 296 Kelvin. Okay, so now what happens here, along with this sulfuric acid, if we take, what happens is that will generate a carbocation, that will generate an electrophile. What is electrophile in nitration? See, HNO3 acts as a base here and sulfuric acid acts as an acid here and generates nitronium ion NO2 plus as an electrophile. So this NO2 plus is an electrophile in nitration reaction, and it will be going at ortho and para positions. Okay, so that you will get OH and nitro group at para position and nitro group at ortho position. And remember here, which is major product out of these two? Okay, one of the interesting question, which is major? Generally, normal, if there is only alkyl groups like that, other electron releasing groups, we will say para product is major. But here OH group and nitro group, between them we will be having intramolecular hydrogen bonding. So due to that intramolecular hydrogen bonding, ortho product will be major. Okay, remember this point. Which is major, they will ask. Okay, right. Nitric acid, concentrated nitric acid, or HNO3 with sulfuric acid. Okay, now what happens here? So phenol with concentrated nitric acid, HNO3 concentrated, what happens is, see, concentrated now, more number of electrophiles are formed. Okay, so that will be attacking on this phenol ring, because phenol is more activated one. Okay, therefore it will goes to all ortho positions and para positions. Okay, nitro group over here and here and here. So what is the name of this compound? I told you at the beginning of this session only, I told you what is the name of this compound. It's a strong acid. It is called as a picric acid. What is that? Picric acid. Okay, so phenol with concentrated nitric acid produces picric acid, remember. Okay, this one will come back. Halogenation of phenols. Okay, what happens? Halogenation of phenols means this. So halogenation of phenols in non-polar solvent and in polar solvent. Aqueous medium means what? Aqueous medium, it's a water now, so it's a polar solvent. What is it? It's a polar solvent. So in non-polar solvent, if you take phenol, okay, so let us say bromination we are doing in presence of this non-polar solvent. Now it will be giving you ortho-para substituted products. OH, bromine at para, bromine at ortho. This kind of products is formed in non-polar solvent. So if the same reaction taking place in polar solvent, like aqueous medium here, so let us say like phenol plus bromine water. Bromine water means what? Br2 in H2. Bromine added to water, because water is a solvent here. So now this polar solvent accelerates the reaction, and that will make the reaction to activate the reaction and make it to produce tribromophenol. Ortho-para positions completely brominated and gives you this product. Okay, so this is the difference between non-polar and polar solvents. Okay, so now what about cold base reaction here? What is the cold base reaction says? Tell me. Phenols react with see, phenols treated with, first of all you add like alkali like NaOH like that. Okay, now it will be converted into phenoxide ion. So that phenoxide ion is treated with CO2, carbon dioxide. Okay, this reaction is happening in presence of NaOH. Okay, so now what it will form? Salicylic acid is produced. So what is that? Salicylic acid. Okay, ortho-salicylic acid, I mean this one, para, like this. Okay, out of these two, which is major product formed? So the ortho product will be major. Why it will be major? Due to intra, not inter, within the molecule now. So intramolecular hydrogen bond. Intramolecular hydrogen bonding is present. Due to that reason, the major product is this one. Ortho product is major. So what is the name of that product formed? Salicylic acid. Okay, remember in the simple way. Now what is the electrophile involved in the cold base reaction? CO2, carbon dioxide. Actually what is happening here? See, it's very simple. First of all, phenol will get activated upon treating with sodium hydroxide. Okay, because it is forming a phenoxide ion, no? O minus Na plus. It's an acid base forms phenoxide ion. So this phenoxide ion is activating the ring like this, giving pi electrons. Okay, so where that pi electrons will goes? Okay, see here CO2 is there now, like this. So the pi electrons here upon shifting attacks over here like this, shifting takes place because carbon in carbon dioxide is electrophilic. Okay. See, to this carbon I am adding, on that we have one double bond O, one O minus is there and one hydrogen here, like this we have. Okay, now next what happens, tell me. Okay, this is an sp3 carbon, right? See, sp3 carbon here, all of them are sp2. So it is aromatic ring becoming non-aromatic. Now what happens, it is losing its aromaticity now, but aromatic compounds are more stable. So you need to regain that aromatic nature. So now how it can happen? Yes, by removal of this proton from here. Okay, yes, like this. So that you will get a aromatic product back with OH group over here and carboxylic acid over here, like this. So you got your carboxylic acid. Upon adding water, it will turns into salicylic acid. Okay, that's it. That is a product. Okay, ortho-salicylic acid is major. Similarly, para product is also formed. Now, what is the mechanism involved in the reaction during the discussion? Tell me. We discussed already these reactions. So, what is the mechanism involved? Electrophile is involved, and that is attacking on the benzene ring. It's an aromatic ring. Okay, so electrophile, this CO2 is replacing the proton H plus now. So one electrophile is replaced by another electrophile. So you should call it as aromatic electrophilic substitution reaction. What is that? Aromatic electrophilic substitution reaction. What is the mechanism involved in coal-based reaction? Aromatic electrophilic substitution reaction. This is also important point to be remembered. Okay. The next Riemann-Tiemann reaction is there. Okay. So Riemann-Tiemann reaction and the remaining topics will be discussed in the next session. Okay. So what are the next session we will be going to discuss on? What is the reaction of phenol with zinc dust? Okay. All these things will be discussed in the upcoming sessions. Okay. So thanks for watching those who are in the live session. If you are new to this channel, please click on the like button, and if you like the content, please share with your friends who are preparing for NEET, JEE and EAPCET exams. Okay. So thank you for watching. Thank you.